Welcome students to this particular session related to control charts. On this particular slide, we are able to see the plotting of a control chart where the mean line is available over here and UCL is suggesting us the upper control limit. Then after LCL suggests us or it gives the data of lower control limit. On x-axis, the sample numbers will be taken and the sample number will be denoted with small k, while the number of items in each sample that will be denoted with small n. So we will select one of the sample first, and then after the quantity that we want to measure or that we want to check, it will be measured or checked for all the n number of items of lot 1 or the sample 1. Then after the mean value of all the n quantities for the lot 1 will be measured, it will be found out, and it will be plotted on this particular chart. So this particular first orange point on the leftmost side available, that is showing us the mean value of a particular quantity, particular physical quantity for all the items of lot 1 or sample 1. Same way for sample 2, n number of items will be there and the measurement will be done for a particular physical quantity, and then after its mean value will be plotted over here. Same way for all the 12 lots, the points are plotted over here. So likewise, all the mean values of all the n items of all the samples will be plotted over here, and where it will be checked whether all the data points or all the mean points are available between LCL, that is the lower control limit, or and the UCL, upper control limit. So ideally, when the process is under control, all the data points, all these mean value points will be available between the limits of LCL to UCL. If any data point is going outside the UCL or the LCL, then after we can consider that the process is not under control and we need some steps to rectify the process. Some corrective steps are required. So over here with light yellow color, the area is highlighted, which is nothing but the normal variation due to chance. It means that if all the data points or all the mean points are available in this particular region, then we can consider the process is under control, and the remain area, which is above the UCL, that is the upper control limit, and below the LCL, that is the lower control limit, that if we are finding any mean point in this particular area below the LCL or above the UCL, then we can say that the process is not under control and we need to rectify the process. We need to correct some of the steps during the process. So over here you are able to see this is a normal area, and while this one is nothing but the abnormal area, means the process is not under the control. Okay, so now we will be focusing on control charts for variables. Later, first, in the previous sessions, we have understood there are mainly two types of control charts: control charts for variables and control charts for attributes. So in this session, we are focusing on the control charts of variables. Now, there are basically two types or two different types of charts can be prepared under this category. The first one, that is nothing but the mean control chart, that is also called as the X bar chart. And the second control chart, second type of the control chart under the control charts of the variable, that is nothing but the range control charts, which also can be called as the range R charts or the range charts. Now, the mean control charts or the X bar chart monitor the central tendency of a process. Central tendency means we will be focusing or we will be finding out where the average mean value is lied on the graph. And in the range control charts, we are going to focus or we are going to monitor the process dispersion. It means that if we are taking one of the sample and suppose 3 items are there, and the quantity that we are going to measure for all these 3, the values of all these 3 items is 1, 2, and 3. So to identify the range for this particular sample, we will subtract the lowest value from the highest value. So the highest quantity, highest value was 3, lowest quantity or lowest value of a parameter was 1. So 3 minus 1. So that will be the range for the sample 1. If for sample 2, same way 3 items are there and the lowest value is 7 and the highest value is 15 of a particular quantity that we are going to measure. So 15 minus 7, that will be 8. That will be equal to 8. So that 8 will be the range for the sample 2. Okay. While when we are talking about the X bar chart and when we talk about the sample 1, suppose the quantity which we measured, those are having the values 1, 2, and 3. So we will take the mean of it, 1 plus 2 plus 3 divided by number of items. So that is 3. So it will be equal to 2. Okay. And for lot 2 or the sample 2, the minimum was 7, maximum was 15, and the intermediate is 11. So 7 plus 11 plus 15 divided by 3, that will be equal to 11. So that 11 will be the value of the mean for sample 2. So likewise, the different are find out, the mean values are find out for plotting the X bar charts, while for plotting the R charts, the ranges are identified. Now going forward, establishing the control limits. Over here, the equations are shown to you. To understand the first equation, we will consider the number of samples are equal to K. As I told you earlier, we will denote the number of samples as small k, and in each sample, n number of quantities of items are there. Each lot is made of n number of items. Okay, so the first sample, for the first sample, suppose n quantities are taken and n measurements have been, we are going to measure one of the value for each piece of a sample 1. So we will have 20 or we will have n different values of that particular parameter for the all items of the lot 1 or the sample 1 or the K1. Okay. Then after the mean will be taken of it. So X1 means it is nothing but the mean of the sample 1. X2 means it will be the mean of the sample 2. Sorry, we will read it as a X bar. Okay. X bar 1. So it's a mean of sample 1. X bar 2 is mean of the sample 2. X bar 3, that is the mean of all the n items of sample 3. Likewise, we will have the X1 bar or X bar 1, X bar 2, X bar 3, X bar 4. Okay. Then after, we will be taking the average of the sample means. It means that X bar 1, X bar 2, X bar 3, suppose 10 number of samples are there. So K will be equal to up to 10. Okay. So X bar 1, X bar 2, X bar 3 up to X bar 10, all will be the summation of all will be done. and then after it will be divided by the value of k, total number of samples. So you will have the value of x double bar. Okay, so x double bar is what? It is the mean of the mean values of a particular sample. Okay, so x bar can be denoted with sigma I is equal to 1 to k x bar I divided by k. Now the another equation is nothing but for the r bar. Now what is r bar? To understand the r bar, first of all we need to identify, we need to understand the value of ri. What is ri? Ri is nothing but the range of the sample I. As I told you earlier, for sample 1, if the minimum value is 1, maximum value is 3. So the range is 2, 3 minus 1. Okay. For sample 2, if the minimum value is 7, maximum value is 15. So the range for the sample 2 will be 15 minus 7, that will be equal to 8. Okay. So R2 will be equal to 8. R1 will be equal to 2. Okay. So likewise, each sample will have a range for it. It will have the Ri value for it. Ri, R2, R1, R2, R3 up to R10. Okay. And then after we are going to take the mean of it, average of it. So that is called as the R bar. And how to find it out? R bar can be taken as, or it can be found out by using this equation. Sigma I is equal to 1 to k Ri divided by k. So basically it is nothing but very simple. You just take the average of all the ranges that you have found out, and that will be the value of R bar. Now let us understand the method to prepare the X bar chart. As I told you earlier, that when we want to plot any control chart, the mean value is required. The UCL or the LCL is required for specifically for X bar chart. So lower control limit and upper control limit are to be found out. So over here in this particular slide, you are able to see the various equations to find out the upper control limit and the lower control limit. In this particular video, this is the first method by which you can plot the X bar chart. If the conditions are somehow different, then another method is also there to prepare the X bar chart. So according to the data available with you, you can select either method. Okay. If the standard deviation has been given to you, if the value of the standard deviation sigma is known to you, then you can refer the process number 1 that we are going to discuss right now. And if the standard deviation is not given to you in the data, or it is not somehow available with you. Okay, so over there, the another method is there, which we'll be discussing later. So basically the X bar chart is used to monitor the central tendency. It means we will be taking the mean value as a reference line. Then after the upper control limit and lower control limit will be found out. Okay, and in this particular first case, we are considering that the standard deviation sigma has been given to us. Okay, so how to find out now upper control limit and lower control limit when the standard deviation sigma has been given to us? So to find out the upper control limit, we have the equation x double bar is equal to z into sigma x bar, while the lower control limit LCL will be equal to x double bar minus z sigma x bar. Now we need to understand the meaning of z, the meaning of sigma x bar and x double bar. X double bar we already have discussed in the previous slide. That is nothing but the average of the sample means. Now if we talk about the value of z, that z is nothing but the standard normal deviate. And always remember that In standard cases, in general cases, the value of Z will be equal to 3. So if nothing has been given to you, you can assume that the value of Z equal to 3. Now, how to find out? So we are able to find out the value of X double bar. We already have discussed the equation of it. Now the value of Z also is discussed in a standard manner. It can be considered as a 3 only. Okay. Now the turn is that how to find out the value of sigma X bar. Now sigma X bar is what? Sigma X bar is nothing but the standard deviation of distribution of sample means. And how to find it out? So sigma X bar will be equal to sigma divided by under root n. Now what is sigma? Sigma is nothing but the standard deviation, which is already given to you in your data. Okay. And divided by under root n, where n is nothing but the sample size. In each sample, a specific number of items will be there. So that specific number of items, suppose 3 or 10, each sample carries 10 items. So n will be equal to 10. If each sample carries 3 items, okay, so n will be equal to 3. So likewise, that is nothing but the small n or the sample size. So by using this particular equation, sigma X bar is equal to sigma divided by under root n. So sigma is already given to you. N will be available to you. So you will be able to find out the value of sigma X bar. And then we will be putting this value in this both of the equations. Z can be considered as the value of this Z can be considered standard 3 value we consider, and X bar. Okay. So if you will plot, if you will find out, or if you will put all these values in this equation, then you will have the upper limit and the lower limit. We will understand all these things with respect to the example. So now over here, you just see in this particular example, the data has been given to you in this manner. A quality inspector took 5 samples. It means the value of sample or the total number of sample is 5. Over here, you are able to see sample number 1, 2, 3, 4, and 5 has been given in the below table. Each with 4 observations. It means that in each sample, there are 4 observations. So small n, that is nothing but the 4. Okay, if you will see in starting from sample number 1 to sample number 5, there are total 4 observations. Observation number 2, 3, 1, 2, 3, and 4. Okay. Of the length of time for glue to dry. The analyst computed the mean of each sample and then computed the grand mean. Over here, you are able to see the X bar value. That is nothing but the average of the value that has been found out by the quality inspector for all items of individual lot has been written over here on the bottom side of the each sample in the last row of the each sample. So that is the X bar value. So if you will do the summation of all these 4 items, 4 values, and if you will divide it with the 4 or the small n, then you will find out the average of sample 1 is nothing but 12.10. Same way, if you will do the summation of this all values of sample 2, and if you will divide it with small n, that is equal to 4, you will find out it as a 12.12. Okay, so same way X bar 3 is equal to 12.11, X bar 4 that is equal to 12.10, and X bar 5 that is equal to 12.12. Okay. Use this information to obtain 3 sigma. It means that Z is equal to 3. Control limits for means of future times. It is known from previous experience that the standard deviation of the process is 0.02 minute. So over here, the standard deviation value has been given to you. That is nothing but the sigma. Okay. So we have the equation of upper control limit and lower control limit. That is equal to x double bar plus or minus z sigma x bar. We will be putting the values over here. We need to find out the values of sigma x bar first of all. So to find out the value of sigma x bar, we have the equation is equal to sigma divided by under root n. Over here, sigma is 0.02 minute and under root n is nothing but the number of items in each sample, that is equal to 4. Okay, so sigma x bar will be equal to 0.02 divided by under root 4. Now let us see the solution of it. Over here, the z is equal to 3. It means the standard value of z has been given to you, and n is equal to 4 per sample, and sigma is equal to 0.02. That is the standard deviation. So we already have found out the x bar values for the each sample. X bar values for sample 1 is 12.10. For sample 2, that is 12.12. For sample 3, that is 12.11. Then 4 for 12.10, and for sample 5 it is 12.12. So we are going to calculate the x double bar. X double bar is nothing but the average value of all the means of all the samples. So 12.10 plus 12.12 plus 12.11 plus 12.10 plus 12.12 divided by number of samples k. So that is equal to 5. So if you will take the mean of each sample, then it is equal to 12.11. Now sigma x bar is equal to sigma divided by under root n as discussed earlier. And sigma x bar is equal to 0.02 divided by under root 4, that is 0.01. Okay, so now if we will put all the values over here, so the UCL will be available with us and LCL also will be available with us. So UCL will be equal to, as per the previous equation, UCL can be given as x double bar plus z into sigma x bar, while LCL will be x double bar minus z sigma x bar. So over here, UCL is equal to x double bar. X double bar is equal to 12.11 that we found out earlier, plus z. The value of z is 3. Multiply with sigma x bar. Sigma x bar is found out as 0.01. So 3 into 0.01 plus 12.11, that will give us the value of 12.14. And LCL, that is nothing but the 12.08. So now we have the values of x double bar, UCL and LCL. Then what we can do, we can plot the x double bar value over here as a mean value. That will be equal to 12.11. The UCL will be 12.14. So obviously it will be above the mean line, above the x bar line, x double bar line. And LCL, that is nothing but the 12.08. Okay, it will be below the x double bar line, that is the mean line. Okay, and then after, what will we be doing? We will be plotting all these points, all these averages, x bar points, 12.10, 12.12, 12.11, 12.10 and 12.12. Okay, on this particular graph like this. So the first value is 12.11. So it has been plotted over somewhere over here. Then likewise, all the points will be plotted and it will be checked whether any point or any mean value or any x bar value crosses the UCL or the LCL. If it crosses the UCL or LCL, then we can say that the process is not under control. But if all the x bar values lies between the UCL and LCL, then we can say that the process is under control. Okay, so let us check whether this particular process is under control or not. So the first X bar point, X bar 1 point, that is 12.10. Okay. It lies between 12.08 and 12.14. It means it lies between LCL and UCL. So this particular X bar 1 point lies between the UCL and LCL. Then let us check for X bar 2, that is 12.12, which is again falling in between the 12.08 and 12.14. Then third one, that is the X bar 3, 12.11. It is also the intermediate point between the 12.08 to 12.14. Then the point number 4 or X bar 4, that is 12.10. Again, it lies between this limit, and X bar 5, 12.12, that also lies between UCL and LCL. It means that this particular process is under control. Okay. So likewise, by finding out all these values, all these points, all the mean points, X bar 1 to X bar 5 will be plotted on the X bar chart. It will be prepared and it will be checked whether any point is crossing the UCL or LCL. And on the basis of that, the decision will be made, or the conclusion, we can reach up to the conclusion whether the process is under control or not. Okay. So after this much of calculation, you need to prepare the X bar chart. And on the basis of those X bar chart, you need to decide whether the process is under control or not. This particular method is limited for the case where the value of standard deviation has been given to you. You can utilize these equations when the standard deviation values is given to you. So this is the case one, or the method one, or the first way of plotting the X bar chart when the standard deviation of the process is given to you. Thank you.